All right, welcome back. We're set for practice exam number 24, and apparently I am having some major screen issues with my office move. Apparently I need to get some more lighting in here or something. It looks like I'm turning bright red or something. Probably the red shirt doesn't help any. We're gonna deal with it today, though. I'm sure that you don't mind. You're not here to look at my pretty face anyway. We're here to do some practice exam questions. So let's jump right into it. See if we can't stump you today. Question number 1, the following log entry is captured during the network performance audit. What specific use case does the payload most likely represent? And we have a little bit of a log here. This really is understanding those ports, understanding those protocols, and then understanding what they do. And if you could figure that out, you could probably answer this question pretty easily. We're not going to waste a lot of time on this one. We are going to move on. If you need more time, of course, you can pause that video. So what does this log tell us? What specific use case does the payload most likely represent? Is it secure web traffic to a management console? I don't think so. We're going to tell you why in a minute. So we're going to get rid of A. Is it encrypted remote administrative commands? Ooh, possibly on that one. Is it secure file transfers to a remote server? Again, another good answer, possibly on this one. And is it encrypted mail transfer? I don't think so. I think it's going to be between B and C. B and C are going to be our top answers today. If you need more time, or excuse me, if you'd like to take another guess at it, if you answered A or D, go ahead and do that now. And if not, we're going to just go ahead and answer it. If you answered B, encrypted remote administrative commands, then you probably know that port 22, which is right here, is SSH, and that we know that SSH is utilized to provide remote administrative commands to our servers. That's where SSH comes into play. As such, B is going to be our answer. Not a hard one. If you know those ports and protocols. Question number 2, a network technician, I cannot talk today, is troubleshooting an issue where users connected to a patch panel experience frequent disconnections. Upon inspection, the technician finds the cable runs terminate on an older Cat5 panel, but the network is configured for gigabit speeds. Which of the following is the most likely cause of the problem? What are we looking at for this one? Of course, we got 4 good answers on the board. Let me move my head out of the way. You probably don't need to see my picture anyway. We'll get my head out of the way of that answer. There we go. Let's see if we can't dive into this one. Let's see if we can't answer this one. Need more time, of course, you can pause that video. Does it A, the patch panel introduces excessive crosstalk, reducing signal quality? I like that answer. I really do. I mean, older patch panel, that is a possibility. The patch panel lacks grounding, causing electrical interference. I don't think so. I think that we can understand from the sentence, from the statement here, that that's probably not the case. C, the cable pairs are incorrectly terminated, causing impedance mismatch. No, I don't think so. I don't think that's what we're going to see here. I don't think so. And then D, the Cat5 patch panel cannot support the bandwidth required for gigabit Ethernet. It's either between A and D. A and D are really good answers. What do you think? What do you think between A and D? I'll give you about 5 seconds before we answer this one. If you said A, the patch panel introduces excessive crosstalk, reducing signal quality, I'm afraid you're incorrect. It's going to be D. D, it even says it pretty much in the question, right? We see the network is configured for gigabit speeds, and Cat5 can't handle those gigabit speeds. That's going to be an issue. There we go. D is going to be the answer. All right, question number 3. A DNS administrator must configure a reverse DNS zone for IPv6 network using the range 2001:db8:1234::/48. What DNS record type should the administrator configure, and which zone name should be used? What is our record type and what zone name? Right. So it's kind of a double-edged question on this one. Now, I do want to point out, if you're reading through this, and you're one of those people that's like trying to find tips and tricks on how to answer these types of questions, you'll probably notice that there's 2 PTRs. I want to caution you from using that as a hint, because a lot of times it's not. A lot of times CompTIA does everything in their power to kind of maneuver you towards an answer. So don't pay too much attention to both of them being PTR. Don't use that blanket as a hint saying it's PTR, because you may get stumped on that. You may get whacked on that one if you're not careful. Let's answer this one if we shall, and we shall, we will. All right, what DNS zone type should the administrator configure, and which zone name should be used? What do you think about that? What do you think about, well, let's get rid of some. Let's get rid of some. Let's get rid of, I don't know. Well, let's answer the first one. PTR 1234 DB8 2001 IPv6.ARPA. .ARPA. You'll notice all 4 of them have .ARPA at the end of it, which is a good indication that ARPA is probably true. Maybe on the PTR. Then we have quadruple A 1234 DB8 2001 IN address. I'm not a fan of this one because it's missing that IP6. It's missing that IP6 right there. Yeah, that's a valuable little hint there. So we can get rid of B, and by relation, we can get rid of C as well because it's missing that as well. So it really comes between A and D. We've got another A and D on this one. What do you think? What do you think on this one? Is it A or is it D? I'm going to turn my picture back on because I like seeing my red face out there. Yeah. All right, let's answer this one. If you said D, CNAME 1234.db8.2001.ip6.ARPA, well, CNAME is not used for reverse DNS mapping. PTR is. PTR is, right? So PTR, right, reverses the hexadecimal notation. So we have the correct reverse of the hexadecimal right there, that hexadecimal, right? And it uses the IP6 ARPA domain, which is what, here. Now we see that as well, but 1234 PTR. PTR is going to be the right one on that one. Yeah, I know. There he is. All right, question number 4. A penetration tester discovers that an attacker has exploited a misconfiguration in a switch to gain unauthorized access to multiple VLANs. Which of the following configurations most likely allowed this VLAN hopping attack? What do you think on this one? What do you think? Penetration tester discovers that an attacker has exploited a misconfiguration in a switch to gain authorized access to multiple VLANs. Which of the following configurations most likely caused the VLAN hopping attack? As always, you can pause the video. Let's start with A. Switch was operating in unmanaged mode. No, I don't think so. I don't think that's going to be a good answer for that one. For a variety of different reasons. But I think we can throw that one out the window. B, native VLAN was not assigned to an unused VLAN ID. Maybe. I can see where that could be a problem. So definitely maybe. C, dynamic trunking protocol, DTP, was disabled. Not a fan of this one either. I don't think it's going to be C. And then D, 8021X port security was implemented incorrectly. Ooh, port security. Definitely good answer on that one. So it's really between B and D this time. I know we've had D's a lot. D's is a lot of possible answers over today. So what do you think? It's either B or D. I'll give you about 5 more seconds to take a crack at this one. What do you think? Well, if you said B, native VLAN was not assigned to an unused VLAN ID, you'd be correct. That's the answer. Why is that the answer, right? So if we read the question, we discovered that an attacker has exploited the misconfiguration in a switch. And yeah, 8021X port security implemented incorrectly, but port security is more about ports. It's not really about VLAN hopping. And so port security would get us maybe into the switch, maybe into a local area network, but not into VLAN hopping. And that's where that native VLAN not being assigned into the specific VLAN ID or unused VLAN ID, that's going to be our most correct answer on that one. And so B is going to be correct on that. There we go. All right, question number 5. A network engineer uses a Wi-Fi analyzer to troubleshoot connectivity issues in a high-density office environment. The tool determines the following data for a specific channel. Which of the following adjustments would best improve network security? Oh man, network performance, not network security, network performance. In this scenario, we see 2.4 gigahertz channel 6, signal strength at -65, noise level at -92, utilization at 85%. Is my head in the way again? It is. Let's fix that. There we go. Get that out of there. There we go. All right. You didn't really want to see my face anyway. If you need more time, you can pause the video. We're gonna answer this one. Which of the following adjustments would best improve network performance in this scenario? We know that it's operating on 2.4 gigahertz. We know it's on channel 6. And if you remember in 2.4 gigahertz, then we have 1, 6, and I believe it's 11 those can all have some really good singular channels without interference, without any type of overlay. So we'd have the maximum bandwidth, but that is not what we're referring to here. If we're referring to here is the Wi-Fi analyzer to troubleshoot connectivity issues in a high-density office. So not really what we're discussing here. So let's start with A, increase the transmit power of the access point. Increasing power will get rid of interference a lot of times. It will break through interference. That is 100% accurate. B, switch to 5 gigahertz channel to reduce interference. Again, another good answer, right? If we switch to 5 gigahertz, we were on 2.4, and we're seeing a lot of interference coming in through it. That could be a good way of getting around it as well. So A and B, really good answers. C, reduce the channel width to 20 megahertz to limit collisions. Yeah, no. We really don't have that capability in Wi-Fi. And even if we did, right? And I know there's some Wi-Fi people out there, and they're like, yes, you do! And I know, right? But more often than not, we're not going to have that capability. And so no, I don't think so. D, deploy additional access points on the same channel to share the load. What? So we're going to deploy more interference onto our network. That makes sense. We're 100% going to do that one. Not. All right, so if it comes between A and B are going to be our best answers on this one. Either we're going to increase the transmit power or switch to a different channel altogether. Switch to a different frequency. What do you think is going to be better on this one? I'll give you about 5 seconds on this one. What do you think? Well, if you said B, switch to 5 gigahertz channel to reduce interference, I have some really bad news for you. Yeah, you don't have to study on this anymore. You've got it right. B is going to be a correct answer on that one. I know, pretty short today. Pretty short. I hope it was beneficial. I hope you learned something. Until next time, I'm Dr. K. We'll see you around.